Changing gears here, if you could get the forces class discussion out, I'm going to go through that with you guys to set you up for the homework assignment that you're going to get right after this class discussion. Okay, so hopefully this will help guide you with the homework assignment that you're going to get, and we can do some practice problems and that type of stuff. Okay, so remember, a force is a vector quantity that describes a push or a pull, and forces are measured in newtons. For right now, we can basically break forces down into two types: contact forces and field forces. Contact force, you have to be in direct contact with it, and the field force, the only one we've talked about thus far and only one we will talk about in first semester physics, is gravity. And the net force is just adding all the forces up in the x direction and finding out like the overall net force, or the same thing with the y, adding up all the forces in the y direction and figuring out the overall net force. And this is kind of just a review from chapter 4. Here we have the directions for drawing a free body diagram. Basically, draw a box of the object, sketch and label all the external forces, and these are the two important steps. First, identify the object's weight, so draw on the weight. Remember, weight always goes straight down. And then ask yourself, what is touching the object? And those are all the forces that are acting upon the object. The only new piece to these directions is that if the force is in not exactly in the horizontal or not exactly in the vertical, you want to break it into components. Okay, so if it says anything about a force is applied, 45 degrees above the horizontal, that's a sign, an indicator to you that you're probably going to have to break that force into components. And then I typically use writing up as positive. If you want to do something different, you can. Just make sure you stay consistent with your sign convention. All right. So those are just the directions for getting forces. Drawing free body diagrams. Here we have Newton's second law revisited again. Remember, F net equals ma, and this is exactly the same bit of information I gave you on the class discussion in chapter 4. The one other formula that I wish I would have thrown in here that I just want to refresh your memory on is to calculate the force of friction, because it shows up a lot in the worksheet that you're about to get. So the force of friction equals mu, which is just some constant. Typically it's going to be given to you, not always, but typically it's given to you, and usually it's a number less than 1. So force of friction equals mu times the normal force. Okay, this formula will probably show up, or be needed, I should say, in the worksheet that you're about to get. Okay, so those are two formulas that you should be familiar with. F net equals ma, and force of friction equals mu times the normal force. Okay, let's take a look at some practice problems. It says object A is at equilibrium. The diagram at the right shows the values of only 3 forces which act upon object A. The vector sum of these 3 forces is blank newtons. Okay, there's a key word that is said here. Instead of trying to break all these, especially the green and blue arrows, into components to kind of figure out what the net force is, you have to pretend object A is like right in the middle. It's being pulled in 3 directions, okay? The big key word is that it says it's at equilibrium. Okay? Equilibrium basically means is the object is not moving. So if it's not moving, there is no net force acting upon this object because there's no acceleration. And so we can say that the vector sum of these 3 forces is actually 0 newtons. It adds up to nothing in terms of a net force, okay? Because they basically are all going to cancel each other out, and this object A, is not going anywhere. Okay, so we don't even need to do any math per se. If you can just kind of realize that equilibrium means I'm not moving, and so since I'm not moving, there is no net force, and so it'd be 0 newtons. Moving on to the back, I guess I should say. It says a sign with mass m is hung symmetrically from 2 cables, which make an angle of theta with the horizontal. And you can take a look at the diagram to the right. The tension in each one of these cables is known as F tension. Okay, so the force of tension on this cable. The vertical component of the tension force, F sub y, and the horizontal component is labeled F sub x. What mathematical statement could be written to solve for F sub y? All right. Now this may seem like, well, what the heck, we've never talked about this, or this might seem a little confusing, but this is really no different than just breaking a force into components. This guy right here, F tension, has some force on it, right? I'm wondering what F sub y is. If we broke this force into x and y components, what's F sub y, and what's a mathematical statement that I could write for that? Well, here's theta, here's some angle with the horizontal, and so I would just use my trig functions. Which trig function would ask for the opposite of this angle? I think it would be sine. Okay, so I can write sine of theta equals F sub y over F tension. And if you were to like try to manipulate this to make it that f sub y is by itself, I would just say f sub y equals the sine of theta times f tension. Okay, so I just cross multiply basically, and there would be a mathematical statement that you could write to solve for f sub y. Okay. Hopefully that's nothing super scary or new, because it's really the same thing that you guys were doing before. Now it's just there's some cables involved instead of like a velocity. Okay. This next problem might take some time to solve, so be prepared to spend a little time on it, but this is kind of what you might see on the worksheet today, at least a few problems like this. Okay. It says, consider the free body diagram shown at the right. If the applied force is 44 newtons and it makes an angle of 33 degrees, the force of gravity is 145 newtons and the coefficient of friction is 0.417, then what is the acceleration of the object? Okay, so there's a lot of stuff going on here. Okay, the first thing I'm going to do is I'm going to kind of write in what I know about some things. So F applied is 144 newtons. And sorry, that doesn't look like a 4, but this is 144 newtons. They also said that the force of gravity is 145 newtons. Okay, so gravity's pulling down on this box by 145 newtons. Another little thing that they tell us is that theta here is 33 degrees. Okay, so I'm just kind of updating my free body diagram, putting stuff in that I know so I can see things a little better. The other thing that's useful to know is that the coefficient of friction is 0.417. That is mu. Okay, 0.417. Okay, cool. What do I do to solve this problem? Well, the first thing I want to do is I don't like this force here at an angle of 33 degrees. I'm going to break that force into x and y components so I can kind of start to get my F net going on, because that's really what I'm going to use here. So I'm going to use Newton's second law, F net equals ma. Okay. So I'm going to redraw this little guy over here, F applied, right over here so I can kind of see it a little better. Here's F applied. I'll call it F applied. And the hypotenuse is 144 newtons. Okay. Now I'm just going to kind of sketch in my x, f of x, and my f of y components, okay? And that's what I'm going to solve for. And this angle here, they tell us, is 33 degrees. Okay, cool. So how can I solve for f of x? Well, I'm going to just, again, use my trig functions. And I think a good trig function might be to use the cosine function, right? So I'm going to take the cosine of 33 degrees and multiply it by the hypotenuse, which is 144 newtons. And if you do that math problem, I get an f of x of 120.8 newtons. Okay, so basically what it's saying is there is an applied force in this horizontal direction of 120.8 newtons. Okay. Then what is f of y? Well, f of y would just be the sine of 33 degrees times my hypotenuse, which is 144 newtons. And if you do that math problem, I get 78.4 newtons. Okay, so what that actually means is that with F norm pointing up, there's another force called F applied, which is going with 78.4 newtons. Okay, that's the hardest part, frankly, in my opinion. Okay, is just breaking this force into components and then updating your free body diagram. I highly recommend updating your free body diagram. I'm sorry this is so sloppy, but as of right now, we can ignore this F applied right here. Okay, just kind of ignore it because we already broke it into components. We know that in the horizontal direction going to the right, we have a force of 120.8 newtons, and in the vertical direction, we have a force of 78.4 newtons, plus whatever F norm is. Okay, well, what is F norm? Well, the normal force is basically there to balance out the force of gravity, and F norm will do whatever it takes to basically not let this box like fall through the floor or not let you fall through your seat. Okay, and so F norm is just going to take the difference between F applied and the force of gravity. Okay, because it needs to account for the extra force, because if it didn't, then basically this box would be accelerating downward through the floor to the middle of the earth or whatever. Okay, so I'm going to take 145 minus 78.4, so this is the force of gravity, just taking that, minus 78.4 newtons. And if you do that math problem, I get 66.6 newtons, which that's kind of a scary number, but anywho. So F norm is going to be 66.6 newtons. All right. So far, I figured out force of gravity because it was given to me. I figured out my horizontal force, 128 newtons, and I figured out my vertical forces of 78.4 newtons and my normal force of 66.6 newtons. What about my force of friction? Okay. Well, to figure out the force of friction, I'm going to take my formula, force of friction equals mu times the normal force. All right. Well, what is the normal force? Well, we just figured that out. It's 66.6 newtons. So I have 66.6 newtons times mu, which they give to us in the problem, of 0.417. And if you do that math problem, I get a force of friction of about 27.8 newtons. So I'm going to put that up here, 27.8 newtons. All right. So now, are we all good? I think we are. We can actually start to figure out what the net force is upon this object. Okay. So notice my vertical forces, 78.4 plus 66.6, adds up to 145 newtons. So there is no acceleration in the vertical. Okay, they balance each other out. But what about in the horizontal? It looks like there might be an acceleration because I have 120.8 newtons going to the right and 27.8 newtons going to the left. So I want to find out the difference between those two forces. I'm going to take 120.8 minus 27.8 newtons. And if you do that math problem, I get 93 newtons. Okay? That, my friends, is F net, which is really an important number because I can now use Newton's second law, F net equals ma. Okay, so my F net is 93 newtons. My mass, dang, what is my mass? Well, that's a great question. They don't flat out tell us what the mass of this box is, right? But there's one more formula, and I'm sorry I didn't mention this earlier, but there's one more formula that you guys probably will want to use, and that is the formula for weight. Remember, weight equals mg. Okay, so my weight is the force of gravity. Okay, so my weight is 145 newtons equals m, which is what I'm looking for, and g is just 9.8. All right, so if I take 145 divided by 9.8, I get a m of 14.8 kilograms. All right, so you just have to use that formula basically to figure out the mass. They don't directly give it to you, but if you use the formula, you're okay. So that's my m is 14.8 kilograms, and then a is what I'm looking for, right? So now I just take 93 divided by 14.8, and if you do that math problem, I get 6.3 meters per second squared. And that would be my answer. That is the acceleration of this box going in the horizontal direction or to the right. All right. Hopefully it's okay. I'm going to erase this right now. If you need to rewind the video, be my guest and pause it if you need to catch any of this stuff. But that would be the answer.